In problem number 1, we've got the discrete random variable x, and it can only take the values of 4 and 5, and they tell us the expected value is 4.2. They want us to find the probability distribution. Now, the problem is we don't know any of the probabilities. We know the x's are 4 and 5, but we don't know the probabilities. Now, one thing we can do is we can say, okay, well, we're going to say when the probability of x equals 4 is x, the other one has to be 1 minus x. There's only 2 of them. We know that has to be the case because they have to add up to 1. So if I were to do this, it would write something like that, x and then 1 minus x. And then you might be tempted to say, okay, x plus 1 minus x equal 1, but you'll notice the x's cancel out, and you're right, 1 does equal 1, but you never figure out what x is. So we're not going to try doing that. What we are going to do is use the expected value they gave us and see if we can substitute that into the formula and then work it backwards and find out our probabilities. So the expected value is 4.2, and we know the formula is all the x's times their probabilities. Well, there's not very many, there's only 2 in this case, so 4 times x plus 5 times 1 minus x, that's going to equal 4.2. And now all I got to do is distribute and combine like terms, and I'm going to find out that I get negative 1x is going to equal negative 0.8, so x is going to equal 0.8. So now I know that this probability for 4, when x equals 4, is going to be 0.8, and then obviously the probability for 5 must be 0.2. So keep in mind, if you've got only 2 variables, then one of them has to have a probability and the other one's going to be 1 minus x. Now to find the variance of x, we take the x squares times the probabilities and then subtract the expected value squared. In that case, it's going to be 16 times 0.8 plus 25 times 0.2 minus 4.2 squared. And that's going to give us a variance of 0.16. And that's all this for this one. Let's go on to the next one. We've got a probability distribution. It's got a discrete random variable x, and they give us information, but we are missing 2 probabilities. We're missing the probability for negative 3, and we're missing the probability for x equals negative 1. They do, however, give us the expected value is 0.75. So what can I do? Well, they give us a hint. We should write 2 equations and then try to solve them simultaneously. One thing I can do is I can take these probabilities and add them up, and they should equal 1. And that's going to end up with a plus b is equal to 0.45. Now that's my first equation. I need to come up with another one that involves a's and b's. And then what I'm going to try to do is use substitution or elimination and try to get rid of one of the variables. The expected value is 0.75. Well, that's the sum of all the x's times their p's. In that case, I'm going to negative 3 times a, negative 1 times b, plus 0 times 0.15. I'd probably leave that out. And then 4 times 0.4. And that's going to equal 0.75. Now, all I've got to do is get the a's and b's by themselves, combine like terms here, simplify. 4 times 0.4 is going to be 1.6, and so now I'm going to take an equal 0.75, and I'm going to get these variables by themselves, so I'm going to subtract 1.6 on both sides and get negative 0.85. Now that's my equation number 2, or b. Now if I take equation a and put it right below it, you'll notice that the one has a negative b and the other one has a positive b. And they're both written in standard form. This is an excellent situation to use elimination. I'm just going to add straight down, eliminating the variable b, and then that gives me that a equals 0.2, and then I plug it back in and find out that b is equal to 0.25. Well, now I got my probabilities that I was missing, and they want me to find the variance of x. And so all I've got to do is use the formula, which is going to be the sum of the x squares times their p's minus the expected value squared. And I already know the expected value, so all I got to do is square these. That's going to be negative 3 squared is 9 times 0.2. 1 squared times 1 is 0.25. And then I've got 16 times 0.4. And then all I've got to do is simplify this and find out that the variance is 7.8875 or 7.893, so you have figures. All right, let's take a look at the next one. In problem number 3, we've got a random variable x, and it takes the values of -2, 0, and 4 only. They tell us the probability when x is equal to -2 is 2p, the probability of x equals 0 is p, the probability of x equals 4 is 3p. So if I wanted to go ahead and start out making my probability distribution, it would look kind of like this. 2p would be the probability with -2, and then p would be the probability of 0, and then 3p would be the probability of 4. And then all I've got to do is answer the first question, is find out what p is. Well, I know these probabilities must equal 1. And so now all I've got to do is find out what p is, get p by itself. P is going to equal 1/6. Now for part 2, they want us to find the expected value and the variance of x. By now, hopefully you know these formulas. It's probably going to be helpful for us to go ahead and fill in the appropriate probabilities in here instead of these p's. 2 times 1/6 is going to be 2/6, and then p is going to be 1/6, and then 3 times 1/6 is going to be 3/6. So we can just fill this in, and then when we go ahead and figure out our expected value, we'll use the formula. -2 times 2/6 plus 4 times 3/6, and that's going to give us our expected value of 4/3. And now we got to find the variance. We'll use the variance formula. That's going to be the sum of the x squares times our probabilities minus the expected value squared. You'll notice every problem I do, I write these formulas. You're not going to forget them if you just get in the habit of doing that. And now all I'm going to do is show my method by writing down what I'm about to do. I'm going to type the rest of it in the calculator and find my answer is going to be 68/9, and I'm done. Let's go on to the next one. Number 4, we've got a probability distribution with an x, but we're missing 2 probabilities, and one's labeled p and one's labeled q. When you have to find 2 different probabilities, very often you're going to write 2 equations and solve them simultaneously. The first equation, well, we're just going to use the property that all these probabilities must add up to 1, and we're going to write this, and then all we got to do is simplify our constants, and we're going to find out that p plus q is going to equal 0.42. And now we'll use the expected value they gave us. That's the sum of all the x's times the p's, and we're going to use the 1.05 they gave us, filling in the rest of the information. And again, we'll have 2 variables, but what we're going to end up here is we're going to end up with 2 equations with 2 variables. And then we're going to use substitution or elimination and get rid of one of the variables. So the second equation is going to be -p plus 2q is equal to 0.39. And see, now if I take the other one and write it right below it, you'll notice how one p is positive and the other is negative. If I add straight down, they're going to be equal 0. So now when I do the other one, it's going to be 3q is equal to 0.81, q is going to equal 0.27, and that means p must be 0.15. So now all I can do is fill those information into our table and go on to part 2, where part 2 they want us to find the variance of x, and the variance is the sum of all the x's squared times their probabilities minus the expected value squared, which in this case they've already given to us. We know that the expected value is 1.05. So all we've got to do is take our x's, square them, and multiply them times their probabilities, and then subtract 1.05 squared. And what we're going to end up with is 2.5875. And that's all she wrote for this one. Let's go on to the very last one. All right, number 5, we got a vegetable basket. It's got 12 peppers. 3 are red, 4 are green, and 5 are yellow. 3 peppers are taken at random without replacement from the basket. So we've got 3 R's, 4 G's, and 5 Y's, 3 selected. And the first thing they want to know is what's the probability that the 3 peppers are all different colors? We're going to use combinations here to figure this out. We're picking. We're going to take a look here. We've got 3 reds. We're going to choose 1. 4 greens. Going to choose 1. 5 yellows. Going to choose 1. And that's all 12 choose 3. And that's going to give us a probability of 3 over 11. What's nice about using combinations, you don't have to worry about the different ways it could happen. What you've figured out is the number of ways to select them. You have all the ways. Anyway, number 2, show that the probability of exactly 2 peppers taken is green is 12 over 55. Well, now I'm just talking about green and not green. So the greens, I'm picking 4, I'm picking 2, and then the non-greens are 8. I'm only choosing 1. I'm dividing that by 12 choose 3, giving me 12 over 55. And then part 3, it says the number of green peppers taken is denoted by the discrete random variable X. So we could draw a probability distribution table. Well, if there are 4 green peppers and we're taking out 3, then we possibly could have taken out 0, 1, 2, or 3 peppers. So we can go and start setting up our table here, and the probabilities I'm going to set up as combinations. So again, we're dealing with green and not green. 4 choose 0, 8 choose 3. That's going to give me 3 peppers that are not green. And then divide that by 12 choose 3. Now if I want 1 green one, it's going to be 4 choose 1 and then 8 choose 2. That's over 12 choose 3. And then if I want 2 green ones, it's going to be 4 choose 2 times 8 choose 3, or I'm choose 1. And then the last one, I want 3 green ones, so that's 4 choose 3. And I don't need to do this but it's 8 choose 0, that's going to be 1. And then 12 choose 3. And all I got to do is figure out these, and I've got my probabilities, which are going to be 14 over 55, 28 over 55, 12 over 55, and 1 over 55. Quickly, I add them up to make sure they equal 1, and then I feel really good about the job I've done. All right, thanks for watching. Hope this helps.